Okay, so today's topic is EDTA method, estimation of EDTA method. So why we have to do EDTA method? What is the use of EDTA method? What is the use of EDTA method? Why we have to do EDTA method? So if you do EDTA method, what do you get the result? See, so if you do the EDTA method, you can identify the hardness of water. Okay, so learning objectives means you will be able to explain the principle of estimation of okay, you will be able to explain the principle of estimation of hardness by EDTA method. You will be able to describe the procedure of this method, and you will be able to perform the experiment, and you will be able to calculate the total permanent and temporary hardness of the given water sample. So these are the uses of EDTA method. Okay. So what is the full form of EDTA? Anybody?
Ethylene diamine tetraester.
Acid. So EDTA full form is ethylene diamine tetraesteric acid, and this is the structure of EDTA. So you can ethylene diamine. Amine means NH. So NH2. Instead of H2, we can replace the acetic acid groups. Okay. So ethylene. Ethylene means two carbons. In means double bond. Okay. CH2 double bond CH2. Okay, so in one H, we can place the another ammonia amine group. So this is the structure of ethylene diamine acetic acid. Okay, so in EDTA methods, the known water sample is titrated against standard EDTA solution using EBT. So anybody know the EBT full form? EBT. EBT means Erichrome black tea indicator. This it is used for indicator. Okay, it is used indicator in the presence of basic buffer solution. Here, basic buffer solution we can take ammonium hydroxide and ammonium chloride. So, what is the chemical name? What is the formula of ammonium chloride and ammonium hydroxide? What is the chemical formula of ammonium hydroxide? Anybody? Ammonium hydroxide full form. Okay, NH4OH. NH means ammonium, hydroxide OH, NH4OH, and ammonium chloride, NH4OH and NH4Cl. So these chemicals are we can take basic buffer solution. So why we have to use buffer solution? What is the use of buffer? Anybody? What is the use of buffer? Am I audible to you? What is the use of buffer solution? So buffer, if you add more amount of acid and or base, it doesn't change the pH. So it maintains the pH range. It maintains the pH range. So if you add more amount of acid or base, it doesn't change the pH. So it means it maintains the pH level. So this is EDTA method. So EDTA, so first we have to take a hot water. So in that hot water, we can add erythrome black tea indicator and EDTA. So EDTA solution we have to take into the burette. This is burette and this is the conical flask. Okay. So while doing titration, we can get the steel blue. First, this is the color of hot water. After add the erythrome black tea, we get the red color, wine red color. So later we have to do the titration with the EDTA. We can get the steel blue color. This is the final result. This is the final result. Okay. So hot water contains mostly carbonates, bicarbonates, chlorides, sulfates, and some more metals. Those are calcium and magnesium. Okay, these are the main components for hot water. So chemical reaction you can observe. Calcium magnesium reacts with EBT. EBT means erythrome black tea. So while reaction, we can get the product calcium magnesium EBT. This is unstable complex and it is a wine red color. Okay. So first we have to, hot water contains calcium magnesium ions. Okay. So that one we have to titrate with the erythrome black tea indicator. So erythrome black tea indicator, we get the unstable complex. That color is wine red color. So when EDTA is titrated against the complex, EDTA replaces all the EBT and forms a stable calcium magnesium EDTA complex. That color is steel blue. The liberated EBT indicates the end point as steel blue color. So, so you get the wine red color. It is an unstable complex. Later we have to again we have to do titrate with the EDTA solution. So we can get the stable complex. So it means it removes the EBT. Okay. So we get the stable complex. That color is steel blue color, and the complex is stable complex that is calcium magnesium EDTA. So EDTA means ethylene diamino tetraester acid. So this is the simple structure of EDT. So in middle we have to mention the ethylene group. Diamine. Di means two. Amine means NH2 NH2. Instead of H2, we place the acid. Ethylene diamino acetic acid. Four acids. Four acid groups are present in the ethylene diamino tetraacetic acid. Tetra means four. Okay. And next principle. So the amount of hardness causing ions can be estimated by titrating the water sample against EDTA using erythrome black tea indicator. At pH of 2.5 to 3.5, Sir, give me host, sir. See, what is the full form of EDTA? Ethylene diamino tetraacetic acid. Okay. So estimation of hardness. So see the principle. The amount of hardness causing ions, calcium and magnesium can be estimated by titrating the water sample against EDTA. So it is using erythrom black tea indicator and the pH is 8 to 10. In order to maintain the pH buffer solution, so the buffer solution is ammonium chloride and ammonium hydroxide which is added. So only at the pH such complexation is possible when when the EBT indicator is added to the water sample. It forms wine red colored weak complex. So with calcium and magnesium ions. So this is calcium magnesium means it is a hot water. The given hot water sample is reacted with EBT, erythrom black tea indicator. So we get the calcium magnesium EBT complex. This is unstable complex and the color is wine red color. When the solution is titrated against EDTA, it replaces the indicator from the weak complex from stable EDTA complex. So what we get before, we get calcium magnesium EBT complex and it is weak, unstable complex. Okay. So later we have to titrate with EDTA. Later we have to titrate with EDTA. So we get the calcium magnesium EDTA complex and it is a stable complex and it is a and the color is steel blue color. Okay. So when all the hardness causing ions are complexed by EDTA, the indicator is set free. The color of the indicator is steel blue. Thus, the end point is the change of the color from wine red to steel blue. Okay. So preparation of solution. So EDTA solution, it is prepared by using distilled water and EDTA. So first we have to take 4 grams of EDTA, means ethylene diamino tetraestic acid. So that one we have to make up with 1000 ml of distilled water. That is that solution is called EDTA solution. Later standard hard water. Standard hard water. That hard water contains 1 gram of calcium carbonate. So what is the atomic weight of calcium carbonate? Anybody? What is the calcium carbonate atomic weight? 100. Okay. So 100, 1 gram of calcium, pure calcium carbonate is dissolved. Calcium carbonate is dissolved in minimum quantity of HCl and then made up to 1000 ml using distilled water. So 1 ml of standard hot water is equals to 1 milligrams of calcium carbonate. It is equivalent to hardness. Okay. So 1 ml of standard hot water is equals to 1 milligram of calcium carbonate equivalent hardness. So EBT indicator, erythrom black tea indicator. So it is prepared by using the chemicals are 0.5 grams of EBT is dissolved in 100 ml of alcohol. 100 ml of alcohol, 0.5 grams dissolved, 0.5 grams of EBT dissolved in 100 ml of alcohol. And next, buffer solution. So buffer solution uses, it maintains the pH. Okay. So what is the range of pH? 8 to 10. Okay. So buffer solution. So 67.5 grams of ammonium chloride and 570 ml of NH3. NH3 means ammonium or dissolved, and the solution is made up to 1000 ml using distilled water. So it means 1000 ml means 1 liter. So 1 liter water. So 67.5 grams of ammonium chloride and 570 grams of ammonia. These two solutions we have to dissolve into the 1000 ml of distilled water, means 1 liter distilled water. So you can take distilled water or demineralized water also, no problem. Experimental procedure. So experimental procedure, first step is standardization of EDTA. Standardization of EDTA. So in the standards of EDTA, burette solution, already you know burette solution. So we have to place the stand. That burette is, see, this is a burette and this is a conical flask. So in burette solution contains EDTA solution. So already you know EDTA solution, how we prepare. So 4 grams of EDTA dissolves into the 1000 ml of distilled water. That one we have to fill into the burette. Okay. So next, conical flask. Conical flask. Already you know conical flask. Conical flask contains 20 ml of standard hot water plus 10 ml of ammonia buffer plus 2 drops of EBT. Okay. So here 5 ml of buffer solution, 2 to 3 drops of EBT and titrate against the EDTA solution taken into the burette. So in burette we have to take the EDTA solution. In conical flask contains the hard water. Okay, what we take in burette? In burette, we have to take EDTA solution. In conical flask, we have to take the hot water. Hot water contains hot water. Which chemicals? Which contents are present into the conical flask? Hot water and 10 ml of buffer and EBT. Okay, hot water, EBT and buffer. These 3 solutions we have to take into the conical flask. Okay. So the end point is the change of color from wine red to blue. So this is the end point, not starting point. This is a end point. So first we get the wine red color. Let the volume of EDTA consumed by x ml. So hot water we have to titrate with first EDTA solution. Okay. So how much amount of EDTA consumed, that one we have to find out. Okay, standardization of EDTA, this is the calculation part. Volume of standard hot water, V1 is equal to 20 ml. And molarity of standard hot water, that one we can um, estimate, that one we can measure with the M1 is equals to the 0.01. And strength of EDTA solution, M2. So we have to find out the M2 means EDTA solution. How much amount, I mean, how much EDTA solution was consumed, that one we have to find out. Okay, here, according to volumetric law, M1 is equal, M1 V1 is equal to M2 V2. So M2 value we have to find out. So M2 is equals to M1 V1 by V2. So strength of EDTA, M2 is equal to 20 into 0.01 by x ml. Okay, and next one is the estimation of total hardness of water sample. Estimation of total hardness of water sample. So total hardness means permanent and temporary. That one we call total hardness. Okay. So same as the above, replace standard hard water with the given water sample. First, this is standardization of EDTA. So in the standardization of EDTA, we take the hard water. Instead of hard water, we can replace the given water sample. What I mean, in practical procedure, we have to take the given water sample. So later, same as it is. So instead of hot water, we have to replace the given water sample. So later we have to add the 5 ml of buffer solution and Erichrome black tea indicator. So given water sample, buffer solution, EBT, that three solution we have to take into the conical flask. In burette contains EDTA solution. Okay, in burette contains EDTA solution. So the end point is a change color from wine red to steel blue. Let the volume of EDTA consumed by ml. So you can see the estimation of total hardness of water sample. Okay, volume of hard water sample. So V3 is equal to 20 ml, molarity of hard water sample. So that one we have to find out. M3 here we have to find out molarity of hard water. So volume of volume of EDTA solution V4 is equals to Y ml. Strength of EDTA solution M4 is equal to M2. According to the volumetric law, M3 is equals to V3. So equals to M4 and V4. So M3 is equals to, we have to find out the M3 value. So the formula is M4 and V4, M4 into V4 by V3. So is equals to YML into M2 by 20. So see, total hardness is equals to YML into M2 by 20. So the 100 value is calcium carbonate value and 1000 is 1000 ml, means 1 liter water we have to make up that solution, that is 1000 ppm. So total hardness, volume of EDTA into molarity of EDTA into 100 into 1000 ppm, volume of hot water sample. So next one is estimation of permanent hardness of water sample. Estimation of permanent hardness of water sample. So permanent hardness water means, so we have to remove the temporary hard water. How we remove the temporary hardness? By boiling, right? By boiling, we can remove the carbonates and bicarbonates, right? So estimation of permanent hardness of water sample means we have to take the 100 ml of water, 100 ml of the same hot water sample in a 250 ml beaker. In a 250 ml beaker, boil it for 15 minutes. Boil it for 15 minutes. During the boiling, temporary hardness gets removed. Cool and filter the solution and make up to 100 ml in standard flask by adding distilled water. Okay, so we have to estimate the permanent hardness of the given water sample. Permanent, only here we have to find the permanent hardness. So we have to remove the temporary hardness. So how we remove temporary hardness? By boiling. Okay, so 100 ml of the given hot water sample, boil for 30 minutes, 15 to 30 minutes, and filter it. So filtrate, what we get the filtrate and the residue. Residue means the solid particles we can call residue, and remaining liquid, that one we can call filtrate. So that filtrate make up the solution to 100 ml. So later boiled water sample. Okay, so pipette out the same procedure as in first step, replace standard hard water with the boiled hard water sample. Okay, so standardization of EDTA, and next one is estimate the total hardness, and third step is estimate the permanent hardness of water sample. So all three steps are same. Okay, so burette contains EDTA solution, in conical flask contains hot water, erichrome black tea indicator, and another one is a buffer solution. That is the first step. And second step, we can understand. Second step contains same EDTA solution in conical flask. Hot water is changed. Okay, so in conical flask contains only what they given hot water. That one we should titrate with the EDTA solution. Okay. So in third step contains estimation of permanent hardness of water sample. So permanent hardness of water means we have to remove the temporary hardness. Okay. Temporary hardness by using sim boiling. Okay. So see, estimation of a permanent hardness of water sample. So strength of EDTA solution M6 is equals to M2. Okay. So next, strength of EDTA solution M6 is equal, according to the volumetric law, V5 M5 is equals to V6 M6. Okay. So M5 is equals to V6 and M6 by V5. So 2 ml by M2 into 20. So permanent hardness is equals to 2 ml into M2 by 20,000, 100 into 1000 ppm. Estimation of temporary hardness of water sample. So temporary hardness of water. So we get the total hardness and the permanent hardness. Okay. So total hardness of water is equals to total hardness minus permanent hardness. So we get the temporary hardness of water. Okay. Okay. So what is the full form of EDTA? Anybody? What is the full form of EDTA?
Ethylene diamine
Are you
tetra.
listening? What is the full form of EDTA?
Ethylene diamine tetra.
Diamide tetraestic acid.
Okay. So how many steps in calculation method? How many steps are present? In calculation method, already we discussed, right? So first step is standardization of EDTA, and second step is estimation of total hardness, and third one is estimation of permanent hardness, and fourth one is estimation of temporary hardness. Okay, so